Hello ladies and gentlemen, this is the next section on chapter 17 about the periodic chart. Last time we dealt with the development of how the periodic chart came into being. This time we are going to talk about the periodic chart itself, what all the different structures and things are, what you're able to tell from the periodic chart. Okay, first off, the basic structure of the periodic chart. You can just see it is divided 1 to 18 in different columns. The term periodic actually just means that it is repetitious. Remember, in development, they figured out a lot of the different patterns related to the periodic chart and how the elements seem to repeat patterns over and over. That's what periodic means. It's something that happens in a regular pattern. Okay, the columns of the periodic table are known as groups or families. More commonly, groups is probably what I'm going to refer to. And the rows going across are generally referred to as periods, and there are 7 of those. You count 1, 2, 3, 4, 5, 6, and 7. Unless they discover some new elements in the near future, we're going to be stuck with 7. Okay, that's just the basic direction of what to call things. Now, the periodic chart is organized in lots of different ways. One of the first ways that the periodic chart is organized, besides atomic number, has to do with what type of substance it is. Okay, first off, if you notice the purple right through here, that is what most of the elements are. And what you'll notice from the key is that these are metals. Okay, so these are things that are going to be shiny, they're going to be bendable, they are going to conduct electricity. Everything that from things that we know about like gold and silver to strange things we may have never heard of before like zirconium and lawrencium. Okay, but they are all considered metals, all of those purple ones. Now, the blue ones over on the right side, those are the non-metals. Okay, so these are things that are gases like oxygen and chlorine, fluorine, and some things that we think of kind of like rocks almost, things like carbon, which would make up coal or diamonds, graphite, sulfur, which is like a yellow plasticky lump substance. Okay, so these are the non-metals, and you can see there's not that many of them. The third type of group is what are referred to as the metalloids. These substances, although they're not a lot of them, are pretty unusual in that they're not really a metal, they're not really a non-metal. They have characteristics of both. So they tend to be a little strange when you talk about their characteristics. Now, you can see the group down at the bottom of the periodic chart, these 2 rows that are kind of all by themselves here. The reality is they fit into this little spot right over here. The reality is this is what the periodic chart would look like if you had it all stretched out. The only reason we don't do this is because the other shape fits on paper better. If we tried to fit out the stretched out version, then it would be hard to fit everything. Okay, so you can see those substances are still metals, and you can see it kind of changes the shape of how you think of the periodic chart, but that's really what it should look like. It's just for convenience that we have it all squashed onto one piece of paper. And you're just supposed to understand that those 2 rows right here fit into that little tiny space right there. And so it's actually this long stretched out version. Okay, now the periodic chart itself is broken into different groups. Okay, if you look across the top right here, it will give you various information. Now you'll see that it goes 1A, 2A, and then you have a bunch of B's that don't seem to be in order, and then it goes 3, 4, 5, 6, 7, 8 for the A's. Now, ignoring the B's for a minute, because the B's are a little weird, the number at the top indicates how many valence electrons each group has. Remember, group is the column. So everything in this first group here has 1 valence electron. Second group, 2 valence electrons. Skipping over the B's. And then you come to 3, 4, 5, 6, 7, and 8. And if you remember when we talked about the structure of an atom, 8 was considered full on a valence level, that outer level of electrons. So they are the ones that would be over on the right when they have that full valence electron level. Now we're going to go through these different groups so that you have an idea of what these different characteristics are for the different groups. Some of them have a wide variety, but there's always something that's in common between them. Okay, first group, group 1A, are called the alkali metals. This includes metals like sodium, potassium, lithium, and they're all in this 1A. Now, as you now know, if it is in group 1A, it automatically has 1 valence electron. Now, it wants a total of 8. So the reality is it's not going to want to hold on to that 1. It actually wants 7 more. Now, because it only has that 1 and really wants to have a total of 8, they actually are very highly reactive. You're not going to find sodium or potassium or lithium in a rock in the ground. They are going to have reacted with something because they just are that reactive, and you'll see that in a little bit. One of the unusual things about them, especially when we think about metals, is that they are soft. Now, the video that you're seeing is actually of potassium, and you can see you literally can just cut it with like a butter knife, and you see all the bubbles and things. That's the potassium reacting with the air. Okay, that's the fresh metal reacting. All of these substances have to be stored in oil, otherwise they would actually burst into flames because of the humidity in the air. Okay, so we're talking about reactive. They are very reactive. To give you an idea of how reactive, we have a video by the King of Random. I'm only going to show you part of it, but what you will see is that sodium is very reactive. If you want to watch the full link, the link is at the bottom of the slide, and you can find out why it's called Don't Flush Sodium in the Toilet. Okay, and here goes.
This is a solid chunk of sodium metal. This stuff is number 11 on the periodic table of elements, and it is extremely reactive if it comes in contact with water. So a few months ago, one of you left a comment asking me to flush a piece of sodium down a toilet, which seems like a ridiculous request, but I have got Cody from Cody's Lab to come out here with his infamous mercury flushing toilet so we can put that experiment to the test.
So this is the same toilet I used for my flushing mercury experiment. I've cleaned out all the mercury, and now I've got a spare toilet, so may as well put it to good use.
Now, if you take a quick look at sodium, it's a very bendy, very flexible metal.
I kind of think it's about the hardness of beeswax. Sodium metal is incredibly reactive. It only has one electron in its outer shell, and so it's actually higher on the activity series than hydrogen.
Now, most people will store sodium in a container of oil because it prevents an oxide layer from forming. I just kept mine kind of in a jar, so you can see it's got that crusty coating. But if we take a knife, we can cut this open, and for a brief second, you can see that shiny metal, but within seconds, you can see it's oxidizing and forms that white, scaly exterior coating. Now, sodium metal does not like to be confined. This piece is only the size, a little bit bigger than a marble, but if we throw this into the toilet and then drop a block of wood on top, it creates enough pressure and enough heat quickly, the wood will get blasted back out 10 to 20 feet in the air, no problem.
Delayed reaction, but that worked. I think it like bounced around and it finally landed on top of it. Yeah.
It's like a good 30 feet from the flush zone. And if you feel this block of wood, it's actually really slippery, really slimy. So check this out. We rigged up this contraption. It's just a long piece of PVC pipe so we can flush the toilet from about 10 feet away. We're just going to drop this into the toilet bowl. We're going to let it fizz around for a bit, and then we're going to flush it and see what happens. Here we go. I can hear it crackling and fizzing.
All right, flush it.
Okay, here we go. Whoa! That's what you call explosive experience on the toilet.
Okay, so if you want to see what happens when they put a large piece into the toilet instead of the small piece, you can go and watch the rest of their video. For us, we will continue going through the different groups, start becoming familiar with the different regions and areas of the periodic chart so that you can use it comfortably. Don't forget to do your homework. If you have